Hello all, welcome to my YouTube channel. First of all, today we will learn a very interesting thing. In the metric sections, we covered a lot of things. We covered the definition of metrics, we covered addition, multiplication, different special kind of metrics, transpose matrix, we covered the inverse matrix. But in the last session, we mainly focused on the orthogonal matrix. And I'll basically show today an example like how orthogonal matrix is helping basically rotate a matrix. Okay, so let's jump into that. And please remember, probably this session will be a little longer because we'll cover a lot of things. We'll recap some of the things. So that's why it will take a little bit of time. But please stay with this. If you learn these things, you'll probably the master of this matrix actually. Okay. Let's first understand a few things. I think I already covered a lot of these things, but let's just recap quickly. One thing is, by the time I'm very sure you're kind of aware what matrix is. Matrix, we are considered m by n dimensional numbers. So basically, the representation can be 1, 2, 3, 3, 4, 5, something like this. And in that case, we can say it's a 2 by 3 dimensional matrix. What is vector? Vector is basically it's basically when you have only columns or only rows. So you can have column vectors or you can have row vectors, but we are mainly focusing right now with the column vectors. Okay. One more thing is how to find the length of a vector. That is basically the norm. So norm. So this is the norm formula. How we are calculating this? This is basically A transpose multiplication or product of A with square root of this one. And how it is happening? If your vector is something like this, because it's a column vector, and then A transpose. So A transpose. Oops, sorry. Why it's not allow me to write? Okay, A transpose will be just a row vector, and then if you multiply, you know the multiplication rule. So A1 will get multiplied with this, you will get this, and ultimately your formula will something like this. Okay, so the normalization or norm is basically the distance of a matrix, distance of a vector, length of a vector. Sorry, and in the previous class when we saw the orthogonal matrix, when you have an orthogonal matrix, like in this case O is an orthogonal matrix with m and n dimension, and A is a unit vector, right? It's a vector, and n by n, and it is m by n, then we can multiply. When you multiply, what will happen? It will create basically another column vector, and you want to try to measure the length of that by norm. So you want to find the norm of this one. So the simple norm formula, if you put, it will be like this, because this is also a vector, this is also a vector, right? So it will be like this. And on the other way, if this is like this, then the norm is basically this one, right? And in the last session, we proved that this is nothing but, so if I just go back to my previous example, which is nothing but the norm of the unit vectors. So, which is nothing but the norm of that specific unit vector. So we will use this concept because this philosophy or this concept will help us to rotate a vector. And how we'll do it? Let's first understand the problem statement, then we will I'll show you how to basically do this thing. So let's first understand the problem statement. Let's consider we have a vector which is represented by R, and its initial point is x and y. So this is my vector, and I want to rotate it. So initial angle was theta 1, and I want to rotate theta 2, and I want to create this vector. So the length of this vector will be same. There will not be any change. That's my orthogonal property actually. I will multiply this with a orthogonal matrix. So R theta will be an orthogonal matrix. I'll multiply this vector. This is a vector. This is a vector. I'll multiply this vector by orthogonal matrix. By a orthogonal matrix, I'll multiply this by a orthogonal matrix, and that will give me the new point. And why? Because if we multiply a vector by an orthogonal matrix, my length of this vector is not changing. That's the thing we proved here. The length of this, even though multiplying these things, will not change the length of these vectors. That's the reason we will need a orthogonal matrix. If you multiply this and if you build the new points, that will not change the length of the vector. That's why you need an orthogonal matrix. And now in this session, we'll basically focus how we'll find out this thing. How we'll find out this thing. This is the part which now we'll cover. Okay, but hope you understand the problem statement. Hope you understand like whatever we covered, like vector, matrix, how to calculate the norm, orthogonal matrix, the very important property of orthogonal matrix, how it's preserving the um, length or distance, everything, so that because of that property we can use orthogonal matrix and rotate a vector. Okay, that's a very important concept. Hopefully you understand it, and I'll now continue. First you understand this, first you understand the problem statement, and now we'll continue how we can basically calculate this orthogonal matrix so that we can get the new points actually. Okay, cool. So let's jump into the finding out this r theta. Okay, so now we will basically just continue and find out this r theta part. So remember, this is not r0, this is r theta actually. Okay, so for this we need a basic trigonometry actually. So let's write down a few equations actually. So x dash will be um, basically r, oops, sorry, it's not cash, my mistake. Okay, um okay, by chance if you are not following, please comments or please email me. I'll provide my email ID so that you can understand anything, but hope this will help. Okay, cos theta 1 plus theta 2, because what is the formula of cos? Early brown hair, right? Cos theta base by hypotenuse, right? So this angle is theta 1 plus theta 2. So in this case, what is my base? My base is basically x dash. And what is my hypotenuse? My hypotenuse is r. Okay. And what is the calculation of r? Y dash is um, sine theta 1 plus theta 2. And what is the formula for sine theta? Perpendicular by hypotenuse. Sine theta is perpendicular by hypotenuse, so perpendicular is this one, which is y dash, by hypotenuse is r. So we found the x dash and y, x dash and y dash. Okay. Now what is the formula of cos a plus b? So simple. Um, cos theta 1 into cos theta 2 minus sine theta 1 into sine theta 2. Okay, and what is the formula of sine theta 1 plus theta 2? That is sine theta 1 into cos theta 2 plus cos theta 1 into sine theta 2. Okay, so now if you again use that same kind of a logic, this hypotenuse by logic, like check basically what is happening. This r cos theta 1, r cos theta 1, r cos theta 1 is basically giving me the x value. R cos theta 1 is giving me the x value, because if you check one more time, cos theta 1 is again base by hypotenuse. So theta 1 base is x and hypotenuse is r. Vex is x and hypotenuse is r. So if r theta 1 is giving me basically the x component, so we can write x cos theta 2 minus, similar way, like if you just do little bit math, so you can check it like this. Okay, and here similarly y dash will be y cos theta plus x sine, just 1 minute. So theta 2, theta 2 and theta 2. Let's just prove it. One, then I can easily understand. Okay, so sine theta 1, so sine theta 1 can be replaced by this, right? Let's see. So sine theta 1 is here, let me write it down. Sine theta 1 is perpendicular, which is my x, by hypotenuse by r. So that's mean, sorry, perpendicular, right? So y. So basically then y equal to r sine theta 1, and that's the reason I replaced this part. Actually, when you multiply this, I replaced it by y. And similarly here, if you do the calculation, you'll see it will come like this. Okay, so now if you try to put it into so basically we got the values of this one. So now you got the values of this one, so you need to find out what is the r theta, right? So let's write it down so that we can do the exact thing. So what we found, that x dash is basically x cos theta 2 minus y sine theta 2, and y dash is y cos theta 2 plus x sine theta 2. Okay, let me erase and write it clearly so that you can understand properly. Actually, I'll not write it here. Actually, let's not complicate it actually, because it's important to understand, right? It's not that just understand. Okay, so as it is writing on the last part, so let's change the color. Okay, so this is x, y, and you found these things. X dash is x cos theta 2 minus y sine theta 2, y cos theta 2 minus, sorry, plus x sine theta 2. So then what will be the value of this r theta? So this is my r theta, right? So if you just little bit do a backtrack, so basically if you are multiplying it, so this will be your cos theta, because if you multiply this, then you will get this cos theta 2, and then you will have sine theta 2, because that then if you do the multiplication, that's the y happening, right? X cos theta minus y sine theta is your first point, and the second point is cos, oops, sorry, I made a mistake. Let me just use the red color for the bracket, and I'll use this one. So second point is basically my sine theta 2, because if you multiply, okay, let me first write it down, then I'll show you why it is like this. So theta 2, and this will be theta 2. Okay, so for the first line, if you multiply, let's see whether it's matching or not. X cos theta 2 minus y sine theta 2, matching. The second line is when you are multiplying it, sine theta 2 plus y cos theta 2. Okay, think let me just understand. Yes, that's the right thing. So this is my r0. Okay, hopefully this makes sense, because this is the way, and now this is basically my orthogonal matrix. This is orthogonal matrix. If you, this is probably a home task for you if you want to try to prove that okay, this is orthogonal matrix or not. So just make sure that you have a matrix like this and check whether this is satisfying these properties or not. So basically the inverse is should be same with the transpose and any other properties, whatever is part of orthogonal matrix, that's the way. But main thing is to understand that because of this orthogonal properties or orthogonal metrics, we can find out, or we can do this kind of rotation of a matrix in the and this is the very important concept. Okay, so hope you like it, and please support me, give me a thumbs up or subscribe my channel. Have a nice day. See you in the next video.